So let's introduce you to the cast of characters here. We have two chemicals. We have iron 3 oxide, which is a red powder, and aluminum powder, which is metal, just like the aluminum foil you use in the kitchen. Except instead of being a solid in the sense of a sheet, this turns out to be a very, very fine metallic powder, just like an aluminum dust. And these are the two chemicals I need to combine together to make thermite. So let's take a look at the reaction that causes it. Alright, so let's go ahead and figure out what we think is going to happen. What I do is I'm going to set up the reaction like we've been doing in class recently. And I say the ingredients I have. So I've got some elemental metallic aluminum. That's a solid. And I can combine it with an iron 3 oxide, which is also a solid. Now this is going to be a single replacement reaction. That's because aluminum is more reactive than iron. So in this reaction, the aluminum can attract the oxide and take it away from the iron and combine with that oxide. And so what we do is we get aluminum, which is a +3 charge, plus an oxide, which is a -2 charge. So you've got to take those and make them electrically neutral. And I'm left over with leftover iron, so that ends up here. And I balance this, and it's not too terrible to balance. And I've got my reaction, my thermite reaction. Now, of course, on its own, that's pretty straightforward, but I need to know how to make this reaction work. I need to know what I need to do, how I need to mix the chemicals so I don't waste it. And of course, that's a stoichiometry question. And so I come over to the periodic table, and I quickly calculate the molar masses. For iron 3 oxide, it turns out to be 159.6 grams per mole. For aluminum, closer to 27. So very different masses per mole, but I know I need to combine them in such a way. And so what I do is do a quick 3-step stoichiometry question, which is, how many grams of aluminum do I need to react with 100 grams of the iron 3 oxide? So I set up my stoichiometry, I do it, it's not particularly hard, we've got a lot of practice doing this at this point. And I multiply through it, I find 33.8 grams. So the math says, to make this reaction happen perfectly, I should take for every 100 grams, I should put in about 33.8 grams of aluminum. That is, I need about 34% by mass aluminum compared to my iron 3 oxide. So I just need to keep this ratio constant, and in theory, all of this aluminum should get used up by all of this iron oxide, and the reaction should happen, and there should be no excess. Now, of course, that's not exactly how things work, but that's what the math says. That's what we've been studying. And of course, getting a theoretical versus actual yield of this reaction will be a bit difficult because, well, you'll see. So before we get our chemistry together, before we prepare the actual mixture, we need to get our reaction vessel ready first. So if we try to do this in a beaker or an evaporating dish, I mean, those things are strong. But one, they're made of glass, and so they don't necessarily hold up to heat very well. And two, they're pretty expensive, so if it were to break, I don't want to be at that cost. A much better choice would be this terracotta flower potter, just like what you buy, put your plants in. This ceramic here is very, very strong, it turns out. One problem, it's got a hole in the bottom. So I've got to stop that so my powders don't come out. So what I do is I just put some aluminum foil in there as a plug, and then I'm going to put a couple sheets of aluminum foil on top. And that makes it a little easier. The powders will sit on top of that, push down on it, and that way they stay in there so the reaction can happen as we want it to, so we're not wasting any of that chemistry. One thing to notice is aluminum powder is pretty dangerous. Aluminum's quite reactive, and when it's a powder, it has lots of surface area. And so that extra surface area means it can react with the oxygen in the air or things in my body really readily. So the first thing I need to do is I need to handle this in my fume hood. The fume hood's going to take most of those powders and keep them away from me. It's going to keep them away from any open flames, which would cause a big fireball. It would keep them nice and contained. Lets me control the reaction. I've got my safety goggles on because I do not want aluminum in my eyes. I've got gloves on so I don't get the powder on my skin and accidentally later touch my face or eat food or whatever. Actually, this stuff is so nasty, I'm going to wear a face mask. So if you don't excuse me, I need this to make sure that the particles don't get into me at all. I want to be as safe as I can around this chemical. And that's one of the reasons why we do this as a demonstration instead of as a lab. So what I'm going to do is I'm going to set up a time lapse of me preparing this. And for every 100 grams of that aluminum powder, I put in 338 grams of iron trioxide. Mix it up, stir it out, weigh it, and evenly distribute it between each of the class's demonstrations. So I'll just film that so I don't have to talk through it, but that's what I'll be doing here. Alright, so that took a while, and even though I was being pretty careful, I left behind a pretty big mess. Which is the nature of working with these powdered metals, which is why we have to be so careful with them, of course. So I'll take the time here to clean it up and then get everything together. Alright, and after all that, you can see where we ended up. Our flower pots are full of the mixture. Obviously this is nothing reacted yet, it's just the mixture of the iron trioxide and the aluminum. And I'll go ahead and cover that up with some aluminum foil to keep moisture out and all that. And that will be it. If you look at our waste here really fast, you can see we used 2.5 kilos of iron trioxide and just under a kilo of aluminum. So each one of these pots is about 500 grams of iron trioxide and about 150 grams, I guess, of aluminum.